both have the same duration, 60 hours, and they were mainly, even though they talk about BIM, they focus on software, and Autodesk softwares, Revit, and Navisworks. During and after the interviews, I identified other diploma courses delivered by interviewee G and interviewees H and I. There is also demand of BIM knowledge from construction organizations. Construction organizations are either demanding in-house software training and consultancies to implement BIM in their practices. 4 of the interviewees are related in these activities. The dissemination of BIM knowledge is basically being done by educational activities. All of the interviewees are related in these activities, either as organizers or facilitators, and they are mainly hosted in universities. Another thing is the emergence of BIM communities. The first BIM forum was created in December 2016, led by 5 professionals of the AAC industry, and I belong to this group. Professional bodies, there is one professional body that is interested in BIM. They have hosted activities, they are interested in delivering courses, and they even conducted a very important talk back in August, which has had a very high attendance. Last but not least, and that was a very important finding, there are future strategies on BIM education. One important university has the plan of inserting BIM in the civil engineering curricula. It involves changing one module. They will teach Revit instead of AutoCAD, and they are also inserting a new module. However, the deficiencies of this integration is that it's not in the whole curricula, it is in complementary modules in the last semesters. And because it will be effective by 2019, it's not an advantage for all the students. And it's, again, focused on BIM software. This is something that you could see in everything, in all the things that I found in my country. However, there are good plans. Most of the interviewees are planning to continue delivering BIM diploma courses, delivering multidisciplinary software training, and the professional body is really interested in delivering educational activities for the professionals of the industry. Other plans that they have is create BIM groups, research on BIM. They want to develop BIM standards for the country and propose the implementation in governmental institutions. To conclude, as you could see so far, there is only provided BIM training in the country, which is prone to expand and is mainly focused on software. The involvement of professional bodies and creation of big communities is something very good for the country because it's kind of spreading the knowledge of BIM throughout the country. The interest in BIM is rising in academia. Even though they do not provide BIM education yet, they are hosting workshops and educational activities. And this plan of integrating BIM in academia, even though it's mainly focused on BIM software, this is something that has been seen in many countries. There is deficiency in how they integrate BIM in the curricula. They do not have BIM open BIM implementation. They don't tend to talk about BIM collaborative process. They mainly start delivering software knowledge first. So this is something that we can overcome as well. These findings suggest that we need support from the government, from the industry and academia, and we need BIM education frameworks for us to know how to implement BIM in academia. Future work, I need to develop, well, I already developed a BIM education framework, which could not be presented now, from a literature review I did on the subject. So I need now to go back to this framework and compare, try to see if it can work in my country through the data I already collected. After that, I can either improve the framework and disseminate other relevant findings from my work. Thank you so much.
Thank you very much, Anne, for the very interesting presentations.
No, they didn't talk about implementing this. My target was construction organizations that basically do buildings. I didn't get to this type of projects. However, these BIM education providers, they were related to BIM education activities. I asked them later, if they were related to BIM implementation practices. Some of them did, some others didn't. But I do not have, in my criteria, I didn't consider these civil projects. Well, after I collect the data, I am still in the process of analyzing. I need to validate all my data. I would need to go back after developing the toolkit to see if it can be something implemented in the country. You know that in qualitative, the numbers are not important. My target was actually see the construction practices in there. With a questionnaire, a survey, I wouldn't be able to get that. So I will need to go back to to some of my interviewees after developing the toolkit to see if everything is worth it. Well, the problem in my country right now is that the BIM education is being delivered basically in the Autodesk platforms. It's mainly in software, and on the top of that is concentrated on this, and that's not the best way. It needs to be open BIM. Well, in the framework I developed, I kind of have a strategy that can be followed either in the industry and in academia. It's open BIM. I do not recommend any software use, for example. And by analyzing the data, I know that the government needs to have a very important role. However, it's been quite difficult to get to the government. And actually, the professionals of the construction industry do not trust. They are not counting on the government for that. So I will need to have two, in the framework, to consider the private sector and the public sector. And because the private sector tends to be more into BIM than the public, I will need to go into the financial aspects, convince them with the return of investment and other advantages from BIM so they can take the step and move into this type of collaboration.
So can I just mention, in Ireland, we're looking at a BIM framework of education, and what we're doing is we're mapping it to, for example, the civil engineer in terms of what competencies, knowledge and skills they need to be able to implement BIM. In terms of more mandating BIM as a process in the construction process, in terms of on the government level. So the civil engineer will have to have some competency skills. Construction manager or project manager will have to have a set of skills. The actual architect will have to have a set of skills, and that will actually, we believe, help in terms of how education then addresses those competencies.
Yeah, it really helps.
Whether across the program, in construction management, for example, it's embedded in the program, or it's actually given as standard.
Yeah, mine so far is very general. I have even checked other frameworks. The one that is more specific is the one from the UK, where they have everything mapped according to the level 2. However, in my country, there is no level specified yet. So I will need to go from general to a specific after analyzing the data. Sorry.
Yes, we now going to our next speaker, Professor Bimal Kumar. He's going to be, Bimal is not here, he's not joining us, and Professor Billy is going to be presenting his paper. But the title of the Scan to Parametric Modeling, a Novel Approach. Could you please welcome Dr. Professor Bill, and he's also going to be giving you a little bit of overview about Professor Bimal Kumar. Thank you very much.
Thank you. As you know, I'm not Bimal Kumar. Professor Kumar is a professor of BIM at Glasgow Caledonian University, and he also he's done a number of research projects in the area, but also advises the Scottish Government on BIM and various other industry clients as well. So he's well versed. He's got a wider remit in terms of digital technology in relation to construction, but BIM is his area of expertise. This paper was written between Bimal and his PhD student Farad, and it's quite an interesting view on parametric models. However, I'm not a BIM expert. I know enough about BIM to understand it, but I'm no means an expert. So this presentation will be quite short, and if you ask any questions, you probably won't get any meaningful answers. Okay. So I was really keen to see the first speaker run on as much as possible. So what's this about? It's about scanning existing heritage buildings, so old buildings and structures which are ancient, so therefore there is no existing BIM model, and how we might transpose that into a parametric BIM model. I'll go forward there. So we'll look at problems that's caused by this, trying to create the retrofit parametric model before exploring the novel idea that Bimal and Farhad are at the moment in the throes of developing. So the paper which is in the proceedings, if you read that in more detail, you'll see a very good overview of what has been written in the literature with respect to this specific area. He also goes into a bit more detail, and I'll cover this in the presentation, about the challenges and the problems in trying to create a parametric model from an existing ancient building. And then his proposal here, as you can see, uses quite a lot of acronyms, which I had to Google last night in order to understand. I did have a short discussion with Bimal about the paper before I came here to Bahrain. Bimal said, "Could you do a presentation on this paper?" And I said yes, and that was the extent of the conversation. So, in terms of the point cloud data, or PCD, my understanding of that is that that's some form of technology that can take information and turn it into data. I'm sure Charles Egby will correct me on that if I'm wrong. And available documents meaning there may be, for example, retrospective 2D documents and other specification or data about the structure. The use of completing that in relation to semantic web technologies, which I understand that to mean some formal way that data can be automated and easily read by machines and computers, which one form is, I believe, is the main type of semantic web technology is the Resource Description Framework, or RDF, which is a very particular type of resource using the triple subject, predicate, objective. So if anyone knows what that means, I believe that in its simplest term, textbook definition that I got from Wikipedia, translates roughly to the sky is the color of blue. So it links ideas and objects together. You can see why this would be useful for BIM, I guess. So the translation then would come from the RDF into what most of us will understand who work in the construction world, Industry Foundation Classes, or IFC, which is the building and construction data that we might be familiar with. Okay, in terms of some background then, I think those who understand BIM technology are well aware of how BIM can aid construction projects in terms of improved accuracy, to improve planning, its ability to be a oh, I'm already good, I'm only 5 minutes. Its ability to allow collaboration, to improve in terms of productivity, and its ability as well to detect clash detection and predict hazards in terms of improving health and safety, and of course its eventual use and maintenance and use of the structure, because the BIM model will stay with the structure for its lifetime. So the first part of the process that we explore is capturing the data that's needed, and we talk about scan to BIM and scan and BIM. So my understanding of that is scanning to BIM is use of 2D drawings and documents, but scanning and BIM incorporates additionally any pre-existing CAD models, which can allow you to link one with the other, thus create the parametric data. Now, at the top of that image as well, I don't know if you can read it too well, it's in the paper, is range-based and image-based data capture. So image-based being things like photos and videos, but the more accurate would be the 3D laser scanning, which is the method that BMAL's proposing, the 3D laser planning, which with a few further steps can give you the parametric model. Here's the problem that we have with our ancient buildings, castles and such like. This is Edinburgh Castle, very famous castle in Scotland, and BMAL and Farad have laser scanned the entire castle, so he's going to sell that information to the English so they can attack it at some future point. So this has obvious, intricate, ornate details which are not available in any BIM software. So that's the source of our problem, okay? So we need to try and create this data, which then becomes very extensive, large amounts of data, which are very difficult to handle and don't fit into any recognized software packages. So this is the bit where I kind of lose what BMAL's talking about. So hopefully there's one or two technologists in the room that can explain it. But the RDF, or the subject, predicate, object, like the sky is the colour of blue, or the tower or the parapet has crenellations which are 600 millimeters long, for example, can link this information together and give you geometric information and give you various levels of detail, LOD levels of detail, which allow you to link one with the other. Now, I'm not sure how that works, but I believe BMAL can answer that in an email if you email him. And I think that's straightforward enough. The aggregation, the capture of the data through the 3D laser printing and any existing documents. But then the difficult part, which at the moment BMAL tells me some of this is being done manually, but the proposal is that this can somehow be automated, that the data processing and standardization before you reach the BIM capture, or the BIM software model. And that document there is the most terrifying one that I've seen. So I'm not sure exactly what that means, but I believe that some form of standardization is required, which will then move it. If I go back a step, which one is the laser pointer? Is it the middle? Yes. So this IFC XML, so the process here, this is the most difficult process to get from one to the other. Once you get into this IFC XML, I've been told by BMAL that the BIM software can then relate to it and create the parametric BIM model, right? If you challenge me on that, I'll just concede that that's fine. And this is that last stage on this, in which I think the code, which links one to the other, allows you to make the jump from non-parametric model to parametric and all the detail that goes with it. Thank you very much.
Thank you. Thank you, Billy, for the...
I'll take comments, but I won't take any questions. At the moment, it's manual, but BMAL seems confident that he can automate the process with the, is it the RDF? The RDF, that's the link between the two, between the cloud point data and the ICF is the RDF. There's a little bit more of it in the paper, so I would recommend have a little read of the paper. And if you're still needing more, I'm sure BMAL will answer an email for you, no problem. Thank you.
Now our next speaker, Professor Yusuf Araisi. Professor Araisi is a professor at Hasan Kalyoncu University in Turkey. He's also the Dean of the Faculty of Engineering since September 2016 and Research Fellow of the Turkish Research Council in Digital Construction with Building Information Modeling. He was a previously reader at Salford University in the UK. He is an experienced researcher with an engineering background. His research spans from building information modeling and process modeling to energy efficiency and sustainability through research and enterprise projects. So please welcome Professor IREC. Thank you very much.
Thank you very much. Good afternoon, everyone. Can you hear me?
Yes.
Yeah, okay. Thank you very much for the a bit lengthy introduction, but it wasn't necessary. Actually, it's actually eating up my time. Billy, you should have told me actually. If you needed less time, so I could have actually used your time. So I didn't know anyway.
Well, we have 3 extra minutes if you want.
Okay. Okay, good. So we have extra 3 minutes. That's fine. So again, good afternoon, everyone. I'm going to make a presentation about a PhD study started about 1.5 years ago. It's the energy efficiency at the the design stage. The student is actually from Iraq, working with me to develop a framework, actually a design protocol. Where I'm going to press to move. Oh, yeah. Right. First of all, to give the rationale, as you know all, the energy efficiency in buildings is important, and and also building morphology, orientation, and also building materials are actually key, in defining at the design stage, and play important, influence on the performance of the building. So that's the general global, the view and rationale for energy efficiency in buildings. But when it comes to the Turkey, it's actually, the situation is actually a bit getting worse, because 80% of energy use is derived from conventional fuel use, and energy normally for per building is actually consumed like more than 1,000 petajoule in 2008, and because of the growth, and it's expected to be like more than 2,000 petajoule around 2020. So, which means there is an increasing negative impact on the environment in terms of energy consumption, cost, plus also CO2 emission. So, as we said, we have to do something because the traditional practice and people generally don't pay attention, or they don't have knowledge or understanding or awareness how important it is to pay attention to the performance of buildings from an energy or life cycle cost point of view, more importantly sustainability point of view. So in this research, we would like to look at what is the orientation, how we can actually select the best orientation, and then how we can actually identify the best material to use amongst available alternatives. So that's the start point. I think in research it will be accumulated and increased other factors into it as well. And for example, in Turkey, the other point is there is some like energy certification, but it is not actually serving for the purpose, which means it's like a ticking pages. Just some paperwork, need to tick the boxes. It's done, but it doesn't mean too much, and people still do the way things they are supposed they want to do. So what the problem is, there is no proper guide or protocol to follow up to pay that attention to the performance aspect. So in this research, what we are aiming to do is develop a strategic BIM framework for energy efficient building design, considering the local values and local factors in addition to those global factors and the influence in the concept design in Turkey. So that the outcome is going to be a BIM-based design optimization framework for energy efficiency in building design. So the research is exploratory case study research, employing a number of case studies, and that will also give us a kind of a learning pace. We will learn through every case study, because I think that's the most appropriate case study, because doing survey with people who are not really sure about what is the outcome will be and how useful it will be. So to develop a practical and accurate and usable framework, we decided to go through the case studies, and then for now we have 4 case studies. It can increase in time, and a residential building, and a new university building, a research center building, a passive house in Gaziantep, and another residential building that will go under retrofitting. So, because in the framework we are not paying attention to technology, but we want to use BIM technologies, okay, to develop the process, that integrated process and other aspects. So in the first case study, we did modeling in Revit and through a GBXML, data interoperability. We also use the design builder. So these are the tools, but there are other tools, of course, can be used. And so the outcome is, for example, if you look at the orientation point of view, with that the red text there is actually showing the existing current orientation of building, and the number 3 showing that 90-degree actually is the best possible orientation, for example, to save energy. So of course, so when you say these numbers, so it makes sense, and then you feel that that could be, you feel that actually you are living it. So it's not, you're not just reading from literature, but you're reading and you're feeling and living it. So you can do a more practical and understanding local values. So you can do more practical, process, a design protocol. So when it comes to the materials and wall selection, for example, hollow block is the current wall material, but aerated brick seems to be a better one in comparison to the hollow block, so because it's actually, needing less energy, and likewise, in terms of, because in that building, for example, there is no, insulation, so because of we don't have any comparative, analysis, but we see that extruded polystyrene is actually the better in comparison to the other one, in terms of again energy saving. Likewise, so windows, we can compare the windows. So double glazing windows is better than that single glazing 3 mm clear installed windows in terms of saving. And what this means? What is all this telling us? So building orientation. So we can say that okay, this is like a hypothesis we are actually going through. Like building orientation should be chosen carefully before deciding on its position and orientation, and then building envelope materials should be selected carefully as well at the early design stage, although there are many alternatives are available. So what? So that means we have to then now hypothetically define a framework which should actually involve a process, an optimization process, and we should also identify a number of rules reflecting local values and sustainability indicators, and also technology point of view, rather than, okay, we are using those existing technologies, these are just a test, you can say, but what should be the technological specification we should actually have in hand, to go through the process. Plus, then in terms of, energy assessment benchmark scheme. So as I said, there is an energy certificate scheme, but it is not used. How we can actually integrate this scheme into this framework, so make it usable, so it's a benchmark scheme, how well or how worse is the design doing according to the regulatory standards. So it's this initial abstract level, framework, and we are actually developing further. So mainly 4 pillars, let's say, design and optimization process, technology components. For example, we want to define, so what is the PV? Yesterday someone mentioned about prosumers, buildings producing energy and consuming energy. So, what is the best tilting position for PVs if you want to install PVs? Depending on the position or tilting, position, energy reap from generation from the PVs may change. So what is the best optimized, position to get the most energy out of it? And design evaluation, local energy performance assessment. So these are the 4 pillars. So in the case study too, so we go through the similar, exercise, but so that also increases our learning. So it's a research center building, for smart home technologies, renewable energy technologies, PV, analysis and monitoring, BIM and simulation lab, and 3D printing facilities. That's the model, for example, we did for the building in Revit. And similarly, for example, we see that, again, the red text is the existing orientation, that 0 degree seems to be the best, in terms of the energy consumption and CO2, for example, emission. And also window type, we see that, for example, what I'm saying is if it was, fine, thank you, if it was actually done through this sort of analysis, the building orientation, because in the campus would have been better in terms of material selection, would have been better. And so it gives some real data. And then, in terms of checking the best material and orientation. So key findings from this, so what should we do? For example, appropriate selection of building orientation and materials would contribute to more than 6,000 kilowatt energy saving and more than 2,000 decrease in CO2 emission for 1 year. So this is just one building. Imagine if you do this for many buildings in a city, so how much saving. So this is giving a better picture for us to understand and appreciate using this sort of approach, and if you tell this to practitioners, so they will understand and appreciate, and they say, okay, there's a case there. And what sort of components we should have in the process, for example. So stakeholders, we need to identify stakeholders clearly and define them their role and responsibilities. I mean, for example, architects generally are not really aware of what they don't actually stay away from this energy assessment, things like that. And I mean, in the morning, for example, Mustafa Al-Shawi mentioned that there is no clear roles and responsibilities so people don't know what to do, where to do, what with whom they should actually communicate, etc. And process stages, we should actually specify, clarify at early design, clear specification for data exchange and requirements, plus performance values. What sort of target performance values we have to define. Local cultural aspects plus environmental indicators. So what is next? So this is where we are at the moment at the research, but the next stage is, this is the third case study. We are developing the process model, but at the same time we are going to go through this similar exercise with the passive house, so which has a real data as well. When I say real data, it's because they are monitoring the energy consumption and energy generation. It's a project already completed in 2013. That's the ecological characteristic of that building. Architectural design, provide energy needed for the from solar energy, and also it provides, energy saving. I think these are the general features of a passive house. So because of the time aspects, I don't want to go through one by one. So in that, I think this is important. For example, in that passive house, total energy generated in 2016 like 26,000 kilowatt and consumed like 20,000 kilowatt. So in 2017, 18,000 and generated, and then 16,000 consumed. So there is also some system in place to test and improve our framework. But this is something we are going to do, to improve the framework. This is where in Gaziantep, the passive house. So in conclusion, so just to summarize, we need to identify a concurrent process, to make accurate and active decisions during the early design stage. And as there are many alternatives to choose in terms of orientation and in terms of building materials, and an integrated process approach would help to define the best alternative for performance. And early collaboration, is needed because at the moment it is not done, but we have to define and show it clearly and in an easy and usable way to the stakeholders or practitioners to ensure that the performance is optimized. And finally, making the right orientation of buildings is important, for in terms of heat gain plus CO2 emission. Of course, this is also associated with the cost as well, cost aspect. This is an ongoing research, as I said. This is it, really. Thank you very much.
Thank you.
There are other factors
yes.
that affect
yes.
building orientation.
Yes, yes.
I said, for example, we talk about the size and shape of the site itself.
Yes.
And then we talk about building regulation and so on.
Mm-hmm.
How does this factor play a role in this case? Mm-hmm. Those other factors.
Yeah. I mean, if you consider actually, at city level or neighborhood level, of course, you have to comply with the overall setting, and that's also, yes, as you're right, we can see at least, you can't get the best orientation, but when you actually apply the existing or the constraint, let's say, orientation, then you can see how much CO2, how much energy will be actually consumed, and then you can actually compensate it, with the other materials or material selection on other aspects. Plus, in Turkey as well, they generally building construction, especially for housing, it is not just done, single standalone building. It is done, but it is rarely and generally outside the cities. If it is actually inside the city, it's actually not one city, a group of houses, okay, kind of a site, like a building site, but there are a number of buildings in it. So you can actually, if you define orientation, not one more building, but you have to define it for number of buildings, basically.
Yeah, the last point you made about when you've got a number of buildings, does that have an impact on the orientation regarding shading from other buildings? Mm-hmm. And a second question, from the paper I see that only 1% of Turkey is solar power, but if that was to increase, would the orientation for optimization of solar power, would that also have an impact? Or are the two orientations the same? Orientation
for PVs and the building, you mean?
Yeah.
Yeah. I mean, as you said, shading is another, you can say parameter, but shading on the PVs or shading on the building. So if it is shading on the building, is related to daylighting mainly. Yeah. Again, it's a climatic conditions, Turkey, the region, and it's actually quite sunny place. So shading doesn't have much impact in terms of energy consumption. But if orientation is important, and shading is important for PV installation. So it may actually have impact on the energy generation from solar. So this is a parameter as well. So we are actually working on, for example, I was saying in terms of technology specification. So what is the best tilting position? We can actually define so the PVs can be installed accordingly to generate the most possible energy from PVs. When I say group of houses, number of houses, like let's say the urban regeneration projects, or urban development projects. So under that scheme, lots of houses or buildings done together, in an inner city area. So in orientation, when you consider the orientation, you have to consider the whole buildings all together, in one go. But the orientation, if it is general, people also have houses outside the city, for example, for weekends or for resting. So in that case, you don't need to actually have any city or local regulations to fit. Your house should definitely looking at west or south or north or northwest. So you can select. You are free on that. Not really, no. Because the point, the research. What is the research question? The research question is the energy saving. So to reduce the energy consumption, and as I said, in Turkey as a country, is actually reliant on energy import, and then there is a huge amount of energy actually imported. So as you said, as you're rightly said, noise and airflow. I mean, not noise, but airflow is also important in terms of the energy consumption and the heating and cooling. Yeah. So that also comes under the passive house the perspective. Because this is a learning curve. I think I can't say much about the noise, but for example, it depends again. It can be an optional parameter depending on where you are going to do. But airflow, something we have to consider, I think.